Alright, good afternoon everybody. Let's go ahead and get started with Unit 7, Lesson 15, Adding and Subtracting with Scientific Notation. Okay? So we're going to mentally decide how many non-zero digits each number will have. So if we take a look at what would happen if we were to multiply these, you would notice that it would be 6 times 10 to the something power, right? Because we're adding the exponents. So here you would have 1 digit. That's non-zero. Similarly, in the second one, you would have 1.5, right? Because 3 divided by 2 is 1.5 times 10 squared. How many different digits? 2 digits. And here, for this third one, it's kind of weird to think about, but you're adding 2 different numbers that are in different place values. So once again, you would have 2 different digits that are non-zero. And here, once again, you also have 2 digits. Okay? So we're going to take a look at these, and I apologize if I cough during this video, okay? Diego, Kieran, and Claire were wondering, if Neptune and Saturn were both side by side, would they be wider than Jupiter? They tried to add the diameters, which are this one and this one. Here are the ways they approached the problem. Do you agree with any of them? Explain the reasoning. Diego says, when we add the distances, we will get... Oh, how dare he just add the numbers. Okay, I'm gonna be honest. He hella wrong. That's not how you add. You need to have the same exponent. Kieran wrote 4.7 times 10 to the fourth as 47,000 and 1.2 times 10 to the fifth as 120,000 and added them. Yup, Kieran knows what's up. Claire says, I think you can't add unless they are the same power of 10. Yup. She says... Oh. That's another way to do it. Yup. So what she did was she converted 1.2 times 10 to the fifth as 12 times 10 to the fourth. Yup. Jupiter has a diameter of 1.43 times 10 to the fifth. So that means it would be 1.43, and we're going to move it 5 times to the right. 1, 2, 3, 4, 5. So that's 143,000. So what's bigger or wider? Jupiter or Neptune and Saturn put side by side? Neptune and Saturn side by side. Because it's 167 compared to 143. A celestial dance. When you add the distances of Mercury, Venus, Earth, and Mars from the Sun, would you reach as far as Jupiter? How dare they have us add all these numbers? So let's look at Mercury. Distance from the Sun. So if we look at the distance from the Sun, we're going to add Mercury, Venus, Earth, and Mars. Okay? So we're going to have 5.79, and we're going to move it 7 times. 1, 2, 3, 4, 5, 6, 7. We're going to do the same with Venus. So 1.08, but we're going to move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. We're going to take Earth, which is 1.47, and we're going to move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. We're going to take Mars, 2.28. We're going to move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, right? Oh, this is going to be really funky to add. You know what? There's an easier way. Let's just add these right here. Since they have the same exponent, we can just add those numbers. Quick facts. That's 2.55, 2.28. That's 385. And then if we move this one to the left, this goes up by 1. So that's 0.79. Yep, it's not far enough. Jupiter is still farther. Add all of the diameters of all the planets except the sun. Which is wider, all of the planets put side by side or the sun? Okay, so we're going to use the same trick, okay? Let's have everything be a power of 4, since we already have 2 of these in power 4. So Mercury would be, if we're going to make it bigger by 10, we have to move it 1 to the left. So that would be 0.4878. We're going to add Venus, 1.21. Earth, 1.28. We want to make it bigger by 1, so we're going to make it less. And then we're going to drop the power by 1, which means we're going to have to move this over to the right. So that's going to be a 14.28. So if we add these, that's a 3, 6, that's 10, 18, 25, 33. That's 7, 11, 17, 19. That's 17.9363 times 10 to the 4th. Now if we look at the sun, we want to make this, sorry, we want to make this bigger by 2, so this means we're going to have to drop this by 2, so that's going to be 0.179363 times 10 to the 6th. So which one's bigger? The sun or all the planets combined? The sun, right? How many times bigger is it? It's not that bigger, it's only about 7 times. So if this is the sun, all the planets would be like this. Like that. All the planets would be like that. It's still pretty big, actually. Are you ready for more? So the MC at a carnival is ready to give away a cash prize. Hell yeah. The winning contestant could win anywhere from $1 to $100. The MC only has 7 envelopes, and she wants to make sure she distributes the $101 bills amongst the 7 envelopes so that no matter what the contestant wins, she can pay the winner with the envelopes without redistributing the bills. For example, it's possible to divide 6 $1 bills amongst 3 envelopes to get any amount from 1 to 6. I'll be honest, my mind is not working at 100% right now, and this problem is confusing me. I mean, you could try it on your own, but I'm not going to spend any time on it. Use a table to answer questions about different life forms on this planet. So here we have a bunch of life forms. We have how many there are and the total mass. On a farm, there was a cow. And on the farm, there were 2 sheep. There were also 3 chickens. What is the total mass of the 1 cow, the 2 sheep? Okay. So we want to find how much what the total mass of 1 human, was it 1 cow? and then 2 sheep. 2 sheep, and there are also 3 chickens, right? So let's add these. 6.2 times 10, well, that's just 62. 4 times 10 squared. 10 squared is 100, times 4 is 400. 10 to the first is 10. Times 6 is 60, but there's 2 of them, so that's 120. And then 10 to the 0 is 0. Sorry, 10 to the 0 is 1, times 2 is 2, times 3 is 6. So the total mass here would be 588 kilograms. Make a conjecture, which is just a hypothesis, about how many ants might be on the farm if you added all these ants into the previous question. How would that affect your answer for the total mass of all the animals? So, how many ants do you think exist on the farm? Okay. If you said 1,000,000 ants, that's actually not a bad guess. If there's 1,000,000 ants, okay? If there's 1,000,000 ants, that's going to be 3 times 10 to the 6th times 10 to the 6th. These cancel out, right? Because that's just 10 to the 6th over 10 to the 6th. So 1,000,000 ants would only weigh 3 kilograms. The change would be minimal. What's the total mass of a human, a blue whale, and 6 ants put together? So first let's calculate the mass of a human and a blue whale, okay? And we're going to do it on this side. So human, we already know is 62 pounds. A blue whale is going to be 1.9 times 10 to the fifth. So that's going to be 19 followed by 4 zeros. And then the mass of 6 ants, well, 6 times 3 is 18, so we know it's going to be 0.00000018. So the total mass is going to be 19.0062.000018 kilograms. 19.0062.000018 kilograms. So what's greater, the number of bacteria or the number of all the animals in the table put together? So if we look at the total number, I mean, just think about it. Do you think adding all of these would be bigger or smaller than the number of bacteria? Mind you, this means there's 10 more zeros attached to this number compared to the other ones. Bacteria for sure. So, when we add decimals to numbers, we need to pay close attention to the place value. For example, when we calculate 13.25 plus 6.7, we need to make sure to add the hundredths to the hundredths and the tenths to the tenths, okay? So now let's take a look at the practice problems. If you're wondering, if you can listen to the music right now and you're wondering who it is, it's Rush. It's an old band from the 70s, I think. Evaluate each expression, giving the answer in scientific notation. Since we are adding these, we can just add the coefficients. So that's going to be 10 times 10 to the 4th, which is the same thing as 10 to the 5th. 3.7 minus 3.3 is 0.4 times 10 to the 6th. And if we move it once to the right, this drops by 1. So that's 4 times 10 to the 5th. They have the same exponent, so we can add the 6.3 and the 4.8. That's going to be 11.1 times 10 to the negative 3. And if we move this one to the left, we're going to... Oh, it's confusing me now. We're making this smaller, which means we need to make this bigger. So we're going to add 1. So that's going to be 1.11 times 10 to the negative 2. And similarly, that's going to be a 0.5 times 10 to the negative 5th. We're going to move it to the right, which means we're going to subtract 1. So that's going to be 5 times 10 to the negative 6. Okay? So write a scenario that describes what is happening in the graph. Where's the graph? So this is the time in minutes, and this is the distance in kilometers. Okay? Maestro is running with a bottle of ketchup. That's what's happening. That's what's happening. He runs, stops, runs, stops, runs. Okay? What is happening at 5 minutes? So what am I doing at 5 minutes? I stop, right? He stops. He's eating fries with ketchup. What does the slope of the line between 6 and 8 minutes mean? So first of all, let's calculate the slope. So the rise, okay, this is 1, this is 2, this is going to be 2.5, 1, 2, 2.5. So the slope is 2.5 over 2.5, which is 1. So it's 1 kilometer per minute. God damn, I'm running fast. I am traveling at 1 kilometer per minute. I'm going hella fast. Apples cost $1 each. Let me write that down. Oranges cost $2. God damn, what kind of oranges are these? You have $10 and want to buy 8 pieces of fruit. Okay. One graph shows combinations of apples and oranges that total to $10. The other graph shows combinations of apples and oranges that total to 8 pieces of fruit. Name one combination of 8 fruits on the graph whose cost does not equal to $10. So 4 apples and 4 oranges do not add up to $10. Name one combination of fruits whose total is $10 that are not 8 fruits altogether. Two apples and 4 oranges. How many apples and how many oranges would you need to have 8 fruits that cost $10 at the same time? The one that's green. 6 apples and 2 oranges. These are super fun. Watch this. Negative 2 times 3x is negative 6x plus 8 is equal to 4x plus 12 plus 6. Add these two to get 18. Negative 6x plus 8. We're going to add 6x because I would rather have positive numbers. That's 8 equals 10x plus 18. Subtract both sides by 18 to get negative 10 is equal to 10x. This means x is equal to negative 1. Multiplying the 1/2, we get 1/2 z plus 2 minus 6 equals negative 2z plus 8. We combine these two to get negative 4 equals negative 2z plus 8. We're going to add the 2z to both sides. This cancels. So we have 8 on this side. Now, 2 plus 1/2 is 2.5, okay? So I'm going to write that as 2.5z. We're going to add 4 to both sides. So now we have 2.5z is equal to 12. And you're going to divide both sides by 2.5. What the heck does this equal? I don't know. But you can just leave it like this. In case you can't see, okay? So I'm going to subtract the 4w because I want to have, I want to have the w's to be positive. Subtract both sides by negative 31. So I get negative 38 is equal to 2w. Divide both sides by 2, so we got w is equal to negative 19. You see, those aren't that bad. You just gotta know what you gotta do. Really, that's it? All right, so before y'all head out, may I recommend an anime? I just binged it this weekend. It's pretty cool. It's called, I think it's called Cells Attack or Cells at Work. It's an anime that follows a red blood cell and a white blood cell, and they talk a lot about the human body and how all the different types of cells in our body work together to fight off infections. I really liked it. Anywho, y'all be safe, all right?